this book. So the tangent problem, which is the driving problem of differential calculus, what at WPI we call Calc 1, and the area problem that drives integral calculus, we call Calc 2. So the basic idea behind the tangent problem is if we have a point, say AB, and we have some graph y equals f of x going through that point, what's the slope of the tangent line to this graph at this point? So if we draw our tangent line, think back to what you've studied already in algebra, in geometry, high school, pre-calculus. We just want to know the slope of this line, rise over run. And that's the really driving problem. And we need to develop a concept of the derivative. So the idea of the derivative, the tool of the derivative, is what we develop to handle this slope of the tangent line problem. That's essentially the main topic of Calculus 1. Calculus 2 asks a different question, and so if we have, say, the interval AB, and we have a non-negative function, so we have a non-negative function on the interval AB, and we want to know what is the area of the region that lies below the curve y equals f of x and above the x-axis on this interval AB. So we're interested in this area here. And it turns out here we need the idea of an integral and the idea of integral calculus. And again, this is essentially what you would study in our Calc 2. It turns out that these two problems are very closely related via the fundamental theorem of calculus. And it turns out that our tangent problem, we use the idea of finding a derivative, which we call the process of differentiation. And then it turns out that the area problem, and this is the key insight of this theorem, is that we're using the same concept of derivative or differentiation, except we're doing it in reverse. And we call it anti-differentiation. And you could say this is the main reason why these are the two driving problems of calculus, is because of this relationship, the idea of a derivative and an antiderivative. And they have this link between the tangent problem and the area problem. So you get into this link into Calculus 2 mainly because we need to develop all of the differentiation material and then introduce the area problem and anti-differentiation. Then we're ready to see the connection. But that we're not going to be ready for that in this course. That would be in a Calculus 2 course. So that's the basic gist. And one could say that the rest of calculus is all just details around these key ideas. So we'll jump in to our first lecture that will be posted very soon. And that will start us off with the concept of limit, which really is the key tool in calculus.